So hello everyone, I'm Michelle. I work at Canonical, the publisher of Ubuntu. And as you can see, that's why there's operating system there. Really excited to share on Run GenAI project at scale securely, from the operating system to the MLOps platform. Who among you here haven't heard Ubuntu? Please raise your hand. So we are in a safe place now. Thank you. Well, I mean, Ubuntu's mission is to bring free software to the widest audience. And aside from the operating system itself, you can run thousands of software packages in Ubuntu. And if you've been a user, you probably love the idea of LTS, where we make sure that Ubuntu is long-term supported for 5 years in the community. But if you haven't heard about Ubuntu Pro, we can extend that until 12 years. And that's the reason why we're talking about GenAI and MLOps platform, because we've seen a lot of data analysts, data scientists, enterprises has been using Ubuntu for their GenAI project. And we wanted to make sure that we cater not just the tools, but of course the secure stack for anyone who wanted to build GenAI projects in the operating system that we are maintaining and publishing. Well, GenAI itself is, it can create original content such as text, images, videos, or even code in response to any user prompts or requests, and of course without the numbers. And I don't think I need to, convince everyone. It's AI, GenAI is a thing right now. Even the CEO of NVIDIA said that, it's just a new industry. But according to Google, 64% of organization wants to adopt a GenAI project. Every day, in each person, 2 hours plus was saved by the business adopting chatbots, for example. Cost savings for organizations, and a lot of people and marketers are using image generation to improve their, not just operational, but of course their services itself. And it's definitely at scale in terms of the market. But if you want to think about GenAI in a broader scope of putting it in a production environment, it's not just about creating a cool project, but actually thinking about the operational side. So in this talk, we will also talk a lot about MLOps, because it's really needed, from the data deep dive to the model creation to the developing of any cool project that you have thought of. But I think the hardest part of putting GenAI at scale is the last part, which is the operational, meaning you release, configure, you monitor, you continuously improve. And we will discuss more about sample of MLOps platform. But since we're talking about GenAI, let's deep dive to a specific example of it. So a specific example of it is the very known use case, which is called RAG, or the Retrieval Augmented Generation. I mean, if you use LLM or any project, the challenge is to make sure that you have an up-to-date information, enhance accuracy of your LLM. You have a broad knowledge base, multiple data sources, but should be able to get the truth from there. And then you wanted to have your own LLM to have a context-specific response. So it doesn't make sense if it just randomly answers anything it wants. And currently, RAG is everywhere, and Retrieval Augmented Generation, which is some sort of like a technique that enhances the accuracy, the reliability of an GenAI model using different external resources. For this example, actually, this is a reference or a blueprint from Opea project, which is the open source, the platform that Linux Foundation is leading for retrieval augmented generation and LLM. It maps different processes from, putting or ingesting your data or information from multiple documents, emails, databases, to the user experience of the person who's using any chatbot or wanted to experience semantic search, from user query, embedding a model to it, saving the data in a database called vector database, ranking and retrieval of information so you can get like the specific info that you needed. And then, of course, inference and the LLM that you will be choosing, some sort of understanding or prompt processing so that there's some sort of intelligence. So if you started already having a conversation, the answer will be based on the conversation. Guardrail to really protect what's the outcome that your chatbot will be giving to you. You make sure that bad words are filtered if you're developing an enterprise solution. And then, of course, the whole user feedback where you involve LLM fine-tuning, specific model repository. The good news with that is that it seems to be like the blueprint seems to have a lot of services. And since we're here for open source as well, there's so many open source projects and services that can actually cater a full RAG solution. And we've been doing a lot of work, together with public cloud, with different hardware silicon vendors to test this and enable it in multiple facets, from CPU-enabled RAG to GPU-enabled RAG, to understanding if it's really accurate and better than not having this RAG as a technique. So this is just an example, and putting this in production will, it will be really hard, and I think security is one of the key and point that I wanted to discuss further. Well, these are the challenges that everyone should think about in terms of this whole machine learning space. In fact, I got this 3-point from a member of OSSF. And, it can be prevalent. Now, LLM, your own ChatGPT, from what they call evasion, poisoning, and the loss of confidentiality. Evasion, or like inferring to the wrong thing, means that, if you want to understand an image and use an LLM to tell you what that image should look like, some attacks can be that people will put some sort of what they call adversarial input in your model to kind of hide and try to, add more context, remove more context until your model doesn't give you the exact result or like the optimal result of your output. An example is I uploaded a flower in my own LLM. Some attacker put some sort of ML models in it, hide it, and then suddenly the answer when I ask what is this photo, then they will say a frog. So it's a very, very dangerous because the context is being changed, and this type of adversarial inputs or examples are really, really hard to figure out and invisible to the naked eye. Another one is poisoning or learn the wrong thing. It's mainly because you poison the data that you wanted to train, and the outcome is altered in a different way. So imagine self-driving cars across the metropolitan of New York, and it was supposed to understand the traffic of all colors of the cars. But then because someone kind of poisoned the train data, they make it all like just detecting the red cars. And imagine how chaotic it will be when this whole system of self-driving cars just identifies the red cars and not all other cars. It will cause a lot of trouble in that metropolitan. So lastly, reveal the wrong thing, which is the loss of confidentiality. Meaning, someone will reveal hidden information, and you don't want that. Banks or health services, I mean, it's probably that they needed, a chatbot to understand, can you tell me patient X and what's wrong with him or her, or else this person will just need to review a bunch of data sets. It will be really helpful to have some sort of ways to understand your patient. But then it's not fun when your whole infrastructure is open to other people to access because you lost confidentiality, because your hidden information will be exposed, just how you deployed your own project. And these are the issues in LLM or in GenAI in general. And it's very important that if we go back to the specific sample, which is RAG, is to secure each of the services that runs, secures the user experience for the people who wanted to do user query and get the answers and results. But everything inside, from your LLM itself to the vector database, which handles all the data, to the whole fine-tuning service for your RAG, and also secure the whole thing, the systems that makes the solution run. Another security issues that is added is we've been talking about the software and the RAG and the services, but the hardware is also very important. Where is it deployed? The infrastructure. RAG or LLM or GenAI is also prevalent to edge devices. So it's really also very important to understand how to make it secure in the hardware where you deploy your specific solution. And lastly, the human factor, which of course it's something that we can control, at least for the user, of if you have a product or services. But of course, if you have architects, data scientists, analysts who's been working on some sort of project, it can be really, really open to misuse if security is not something that is a priority. So that is other security issues that is added. And now we are deep diving into the example again about the retrieval augmented generation, where you think about vector database, an example, OpenSearch, Milvus. Maybe I only have bias because I work closely with OpenSearch for some retrieval augmented generation use cases. But think about all these components for your data and AI application to run RAG. Where do you deploy it? In your own machine, maybe a private cloud, a public cloud? What is your OS of choice? Is it secure? What is the hardware you're running it? And this whole stack of assurance of security of your GenAI deployment is very important. And I wanted to share to you a couple of open source RAG tools and infrastructure that us at Canonical itself are supporting. Charmed Kubeflow, for example, is our MLOps platform. It's a CNCF project that enables professionals to deploy, develop AI models. MLflow for experiment tracking. OpenSearch, as I mentioned a while ago, can be a vector database. On the RAG architecture, it can be used for semantic search. It can be used for prompt processing. It can do good integrations with LLMs. It can even serve models. So there are so many tools in the open source world to make RAG work. It depends where it fits in your use case. And the bottom part is your choices of the infrastructure you wanted to deploy in a Kubernetes, in a private cloud, in a public cloud. And then, of course, Ubuntu. I'm a bit biased here because I work at Canonical Ubuntu. And then thinking about the hardware that you're running, your CPU or GPU choices, Intel, NVIDIA, AMD. This whole stack is very, very important on the security of your whole GenAI project. on top of the operational part that I mentioned a while ago, which is the monitoring and making sure things are continuously improving. A little bit of information as well for Ubuntu is that we have this solution called Live Patch, where we actually periodically checks the kernel patches and applies them to the hardware without a need to reboot your server. And then if you wanted to actually plan for some sort of patching time and operational rollout, you can also do that in Live Patch. On top of that, at Canonical, we care so much about the software that runs in Ubuntu. So like the concept of the LTS for Ubuntu itself, which is the long-term supported 5 years, we also have that for the application that runs in Ubuntu. So it's something that we focus so much, the security of the applications that is in our operating system. But aside from that and what we do in the operating system itself and the application and the infrastructure that Ubuntu can run to, or application that runs in Ubuntu, I also wanted to discuss about confidential AI. I think it's fairly originated already in 1970s, but you can really see it much more now with the GenAI use cases. There's some sort of intersection between artificial intelligence and confidential computing as a concept. So a little bit of background, and for sure, a lot of people here are already very good with all the security topics and the data security topics. And we all know that there's a lot of technologies out there that make sure that you're safeguarded when data is at rest and when data is in transit. It's a very strong security value proposition. However, securing data that is in use is something that still vulnerable to potential breaches. What do I mean by data in use? When the data is actually in use, it resides in a clear text, unencrypted in the system memory or DRAM. Otherwise, we cannot really use the data for compute or any CPUs or GPUs. So then that makes it vulnerable for administrators who are actually operating and accessing those servers to any security risk. And to address that data in use problem or vulnerability, confidential computing comes into play because you will protect your data using some sort of what they call like hardware-based trusted environment that will make sure that both your code and data are protected. So these are some sort of numbers and flows where there's really this trusted execution environment between the hardware. So not just CPUs, but also GPUs and the applications that run and the guest OS that runs. Because if you don't have that, you are vulnerable for any attack that comes from hypervisor and host OS. And imagine if you are in a healthcare system and healthcare organization, you don't want your patient information to be open to public when I have my own chatbot. So I think that's what we are addressing with the confidential computing. The confidential AI as an idea came into picture because then you talk about machine learning, you talk about protecting the confidentiality of your data from the machine learning model to the inference, to the prompts, to the LLM responses, and all this data and AI lifecycle. Actually, at Ubuntu, you can run what we call the confidential VM or confidential virtual machine. We have partnered together with some silicon partners such as Intel, AMD, and also NVIDIA. We also have done a couple of partnerships with Google Cloud and also Microsoft Azure. to make sure that you can actually run a confidential VM in Ubuntu in all this chosen CPU or GPU hardware that protects your data, your code, your information with this protected or trusted environment setup. And we also have a KubeCon keynote about it. I think I probably made it a bit bigger to know more if you wanted to know more about confidential computing or confidential AI. To close this, of course, best practices are needed to make sure if you plan to do any GenAI related project, retrieval augmented generation project, secure design and architecture, secure software, CVEs are being addressed, monitoring and anomaly detection. There's a lot of tools for that, access control, and making sure that security is on top of your organization and educate. Now that AI is and the topic is everywhere, it's very important that especially when we put it into production, security and people are well educated in the topic. I guess that's it. This is some sort of life cycle when you start your own GenAI project. It's a lot of journey from proof of concept to scaling it into production to making sure it optimizes. But every step needs some security. That's it. Thank you.